Yes.
Perfect. Okay, so this is optimization problem, and we'll solve this using Scipy. So what does it say? It says that there's a company called Indigo. It's a manufacturer of notebooks and desktops. They make quarterly decisions about their product mix. Okay, so they want to know how many of each product to produce in order to maximize profit for the quarter. Okay, and of course they have constraints. So constraint says that each computer, okay, so notebook or desktop requires a processing chip. Due to tightness in the market, their supplier has allocated only 10,000 chips to Indigo. Okay, so how do we read this? So they want to maximize their profit. Okay, and how many how many desktops and computer in notebooks should they manufacture? So let's go ahead and build this problem step by step. So I'm at the PyCharm now. Okay, I think, yeah, this is where we are. Okay, so optimization using Scipy. So let's assume that D is the number of desktops and N equal to number of notebooks. Okay, so first we are talking about desktop and notebooks. First constraint they say is that due to the tightness, they can only allocate 1,000, right? 1,000 processing chip. That means, okay, in processing chip, okay, if you talk about processing chip, your D plus N has to be less than equal to 1,000, right? This is the first condition. D plus N, because they uses each of them use one processing chip. Okay, so D plus N is less than 1,000, right? So they cannot use more than 1,000, right? You cannot manufacture more than 1,000 N plus D. This is your first constraint. Okay, now this is different than what we did yesterday because here you have less than sign also. Okay, what's the second constraint? So these are constraints. Okay, now if you go back to the screen again, it says each computer requires memory and memory comes in 16 MB chipset. This is the old problem. So ignore MB, make it call it as 16 GB chipset. So notebook needs 16, okay, while desktop has 32. Okay, so notebooks need only one memory, but your desktop will need two memory card. Correct? Yes, no.
Yes.
So if we go back to our and maximum they have is 15,000. So if you go back to our notes, okay, what it says is 2D plus N, because two memory cards are required by desktop.
Desktop.
So 2D plus N should be less than 15,000. Is it 10,000 or 1,000? 10,000, right? Okay. And there's one more constraint. Each computer needs the manpower. The assembly time, machine time, due to tightness, a notebook, due to tight tolerances, a notebook computer takes more time to assemble, 4 minutes versus 3 minutes of a desktop. Okay, so 4N 3D should be less than or equal to 25,000 minutes. You can't, use more than 25,000 of assembly time. Okay. So if you go back to our PyCharm, here it says 3 desktop plus 4 notebook should be less than or equal to 25,000. Right? Next what? Okay. Now it says notebook generates 750 rupees profit and desktop generates 1,000 profit. Okay. So what is the maximum profit, okay, that company will make? Okay, maximum profit company will make. So let's solve it. Profit is 1,000 into desktop plus 750 into notebook, and this is what we need to maximize. Okay, this is also called as linear constraint, okay, or your maximization problem. So let's start solving. We'll read data as matrices, right? So to read data as matrices, this is the constraint. We have to read this as matrices, right? So to use matrix, we have to import numpy. Okay, so you assume that numpy is going to be used almost everywhere from now on. Okay, so you have numpy. Now we need to use so here, okay, in Scipy, we only have minimize. Okay, so we can only minimize. So we know how to minimize, right? If this is to maximize, okay, then we can write minus 1,000D minus 750, and this is what we need to minimize. We discussed this yesterday, right? That if you minus both the side, if it is equal to, then there is no change, there is no impact. But if it is greater than, it becomes less than, like 10 is greater than 5. But if you minus both the sides, becomes minus 10 and minus 5. So you have to change the sign. Minus 10 is less than minus 5, not greater than minus 5.
Yes.
Yes. So the problem, see, we only have function to minimize the problem. But our question is to maximize this. So in order to maximize, if we multiply with minus both the sides, it becomes a minimization problem. Okay, so I'm going to call import Scipy. Okay, okay, let's directly import the function. So instead of import, I'm going to say from Scipy dot optimize import minimize. Okay, now let's see how to frame the problem statement. So let's say D equal to, okay, 1, N equal to 1. So we are assuming that we will make only one desktop and only one notebook. That's assumption. Okay. Now, does it satisfies all the equation? Yes. Right. So you have 10,000 memory card, but you are using only 2. Okay. And so even all these constraints are, it's matching those constraints. Only thing why we have to work is this is probably not the maximum profit, right? We can increase the number of laptops and desktop, but to begin with, let's assume we have one desktop and one laptop. Profit for D is 750. Profit for notebook is 750. Desktop is 1,000. Okay. Okay. So these are the things that we need to start working on. Now, total profit is going to be what? Your D into profit D plus n into profit n, correct? Profit d into t plus profit n into n, okay? This is your total profit that you will get, okay? Now, what is our objective? So objective, okay, this is how you write objective. So you will pass objective as a list, okay? You'll pass objective as a list, and you will only give, this is your objective, right? Okay, you only pass the coefficient, okay? Now, order is important, okay? In which order? So if I give D first, okay, everywhere else in the matrices I have to give D first, okay? So let's put um, um, your profit, okay? So D first, right? So profit minus profit D, and this is your minus profit N. This is what we want to optimize or minimize in this case, right? Now, what are the constraints? Okay, so these are called left-hand side constraints, and these are called right-hand side constraints. So, okay, um, your left-hand side constraints, okay, on the left side of equal, I mean, inequality is your left side constraint. So I will call it as LHS constraint or something like that, equal to, now we'll have to form the matrices, this matrix. Okay, so first is, remember we have taken first D, so we have to take D only first. So it is 1 comma 1, correct? So first constraint is 1 comma 1. Second is 2 comma 1. Third is 3 comma 4. Okay, so these are your left hand side constraint.
Yes.
Now what's your right hand side constraint? Right hand side constraint will become your 10,000, 15,000, 10,000, 15,000, and 25,000. Okay. Okay. Now, you can also, okay, put some boundary condition. Okay. Now, what boundary says is, now let's say here we don't have this statement, but let's say if there was a statement saying that demand of notebook is one maximum only 300, for example. It means you cannot manufacture more than 300 notebooks, right? Or you have a commitment to give to your customer that you know there's a commitment, there's an order, pre-order of 100. So it says that minimum 100 notebooks you have to give. Okay, so your problem can have those boundaries. Okay, like maximum boundary and minimum boundary. Minimum is when you have made commitment to your customer. Okay, that we will deliver you 5,000. Now, if you have to, if you made that minimum, then you cannot manufacture zero, right? You have to manufacture at least 5,000, right? Because you have made the commitment. So even if it is at loss, you will have to make it. Okay. Second thing is upper bound. Upper bound could be that, you know, demand for this is, okay, only 10,000, right? So you can only manufacture 10, maximum 10,000. Yeah? So based on the problem statement, you can define. But here we do not have any such boundary conditions, isn't it? So when you do not have any boundary condition, okay, we can use values from 0 to infinity. Okay, so left side it is 0, comma, okay, float of infinity. This is how you say infinity, plus infinity, right? So you say from 0 to plus infinity, any value can be taken by desktop, number of desktop. Okay. So boundary condition for number of desktops. Now here too, you have 0 to infinity. But let's add some, some boundary from our side. Minimum 10, okay, minimum 10, and let's say maximum, see 25,000. Okay, so if you see here, n cannot be more than 10,000, right? Even if you make all notebooks only, you can make only 10,000 because that's the number of memory cards that you have. So the maximum answer would be 10,000 only,
10,000.
right? So let's put 10,000. If you want, you can put 20,000. Again, I'm just showing that how to give different set of values, okay? Here also you can give 0 to infinity, not a problem, okay? So why this is not closing? Yeah, okay. We just added some condition, some limit for notebooks, okay? Just to show you that, this is how you can add the limit, okay? Now comes the optimization problem. What is the optimization thing? Optimize, okay, let's put optimize what? Optimize, okay, we have to call linear programming. So, okay, so linear programming is also here, I think. Yes, you have to call lin programming. Okay, so linear programming is what this is called linear programming. Okay, the maximization and minimization problem. Okay, yesterday we discussed about few examples. So you have linear programming is for this kind of constraints when you have transportation problem is when you talk about how much to transport from one location to another. Okay, you have queuing problem when we discussed about how many counters to open. Okay, now coming back to our optimization. So you have lin prog. Okay, now here you need to give C is your objective, obj. Okay, you see this cross means this function has been deprecated in this version of Python. Okay, in 3.10 this is deprecated. That means in future this function will not be there. Okay, they would have got some another function. You can search. Let's see with what function they are replacing in future. So linprog is deprecated. That means you can use it for now. Okay, but in future version this will not be there. That's what underscore means. Okay, future version you will not have linprog, but in this version you can still use it. Okay, so we can still use it. So we'll go ahead and use it. C equal to objective. Okay, then you talk about upper bound. Okay, A underscore upper bound. Okay, now upper bound is your left hand side. Okay, B is, okay, A is left hand side, B is right hand side. So if I say A, okay, so I will say LHS constraint. Then B, now UB, okay, means upper bound, yes. Okay, now you see you have AUQ. Okay, if it is equality, then you use AQ. Okay, if it is not equality, then you're talking about bounding. Okay, bound means condition, less than, greater than, right? If you have equality, okay, now you say A equal to, if it was like equal to, right? If it was not less than, if it was equal to, okay, like the previous problem, then you can use AUQ. Why is it called upper bound? Why not lower bound? Because when you do minimization, right, it is always upper bound. Okay, and we are doing minimization anyways. Okay, so now this is your left side. Now same thing if you have to do for B. B, okay, here it's going to be your RHS constraint. Okay, and provide the boundary. So it's called bounds. Bounds equal to, what is that? Boundary. Okay, this is what we have to give. Okay, now the method, okay, that we are going to use, it's called simplex method. So we'll say that we are going to use revise the mathematics, okay, is called simplex. So I'm saying that I'm going to use simplex method. Okay, so how to find the maximum value? Okay, the most common, of course, is simplex, and what it does is it tries to generates values. Okay, it will try with 1 1 2 2 3 3. Okay, that's how it tries. There's no other way to solve this. Okay, and it will generate multiple values, generate so fast, of course, that we feel, we got answer immediately, but it is trying with all sorts of values. All sorts of values it is trying. Okay, so simplex. Okay, now comes your answer. Okay, this is enough. Now, if we have got everything right, it should give us the answer. Let's see. Hopefully, we've got everything right here. It's calculating. You see this? This is the result of optimization. Okay, this is the equation we gave. Optimization terminated successfully. Okay, that means it is able to find the value. If it was not able to find, okay, you would have got that failure. Okay, that means you cannot trust the result. When you say successfully, that means you can trust the result. So you can always look for this message, okay, success. If success is true, only then you do it. What it says is function. This is the output. This is the minimum, okay, because we do minimum, right? It says minimum profit. So that means you convert into multiply this with minus. This is the maximum profit you can get. And how many desktops? Okay, 7,000. 7 into 10 power 3. So 7,000 desktops and 1,000 notebooks. This is what we need to manufacture. Okay, so if I have to print the same statement here, I have to say if OPT, okay, if OPT dot success. Okay, this is the variable that we are going to use. Okay, so if OPT dot success, only then you print. Okay, print what? F, okay, number of desktops equal to, and number of laptops equal to, since we are doing minimization, right, we have to multiply this with -1. Maximum profit that can be, you cannot generate more than this. Okay, of course you can generate less than that. Okay, let's say your market demand goes down. Okay, so maximum profit that can be generated equal to, I can directly say here, right, -1 into, okay, your OPT dot fun. Okay, number of desktop is OPT dot X. So OPT dot X again has two values, the list, right? So I need to get desktop will be OPT of X dot 0, and OPT of X of 1 is number of laptops. Okay, of course, if it is not success, okay, if it is false, success is false, okay, you can say solution cannot be generated. Okay, now you run it and you should see the answers here. So number of desktop 7,000, number of laptops, okay, 1,000, and maximum profit that can be generated is this, which is 77 lakhs 50,000. That's the, and this is for quarter, right? So this is the profit that you can generate for a quarter. All right. Any questions so far? So this is one application of Scipy. There are many applications of Scipy. Okay, as name suggests, it's scientific Python. So all the scientific operation, all the physics kind of problem, all mathematics kind of problem, You can solve using this. Okay. Shall we move ahead to pandas? Okay. Important for us. Okay. Because pandas has data frame which resembles your table structure. Okay. So we are dealing, when you want to deal with table, you have to use pandas. Okay. Now, let's learn how to create our own table. Okay. We'll see how pandas data frame looks like. Okay. Let's see how it looks like. So what I'll do, I will create empty data frame, let's say first. So data frame df1 equal to, of course, you need to import. You need to pip install first, okay? Just like NumPy and SciPy, you have to install pandas. Only then you can work with it. Import pandas as pd. Then you say df1 equal to pd dot d capital f capital data frame. Okay, this is how your data frame will look like. So print df1, you want to say the type, you say print type of df1, and when you run this program, you see it says empty data frame, columns none, index is rows. Okay, rows are called as index and columns are called columns, obviously. And type is class.code.frame.data frame, pandas data frame. That's why we say pandas data frame. This is the data type of data frame. Now let's say we'll build a table here. So I want to build a table for fruit production or something like that. Okay. So you say, okay, so first let's take data, something like data, and we'll have list of list. We'll create list of list. So this is going to be one row, second row, third row, fourth row. Okay, we'll have 4 rows. Each of these will have first fruit's name, so apple. Then you can have, let's say, first column will have fruit, second column you will have, let's say, quarter one or month one production. Okay, quarter one production. So quarter one production, let's say it is 15,000 kilos. Okay, 11,000 kilos. Let's say 6,000 kilos. Okay, so this is your first fruit. Second fruit, we'll put banana, and again we'll give 3. So we'll say 18,000 kilos, 22,000 kilos, and 29,000 kilos. Okay, third fruit, let's add mangoes. Okay, so here you have 2 kg, here it became 900, and then it is 19,000 kilos. Okay, then let's say we have guava. Okay, so guava is, let's say, 19,000. Okay, 11,000, 25,000. Okay, so this is a simple list, isn't it? Now we have to convert this into table. I want to convert this into table. You simply say, sorry, fruit production. Let's say I want to call this as fruit production equal to pd dot data frame. Okay, so what did we use to convert list to NumPy object, matrices object? Which function did we use? Which function did we use to convert list into NumPy or matrices? Array, NumPy dot array. Remember that. Okay, just have to remember 2 functions: array to convert list into matrices, and data frame to convert list into data frame. So here I'll say data frame data. Okay, now you can print fruit production. So if you print fruit production, okay, you get this. This is the table, okay. First value, second value, third value, fourth value, okay. These are the, okay, next column 2, column 3, column 4. Now you see, we have not given column names, okay. Since we have not given column names, it is using number here. Since we have not given column name, it is using number. What is the number? 0, 1, 2, 3. Okay. That means this is your column 0, column 1. So if you do not give names to column or to the index, to the rows, it will use its own way to access each row. Okay. So if I want to know third column, second value, third column, second value. So it will be row 1, column 2, index 1, column 2. Okay. This is how this will be accessible. Now, if you want to give, let's say you want to give name, right? So you can give name here. Okay. So here I can say columns. Okay. So here when you convert into data frame, you can say columns. Columns equal to, and you give them in the list form. If you want to give row name also, you can give row name also. Okay. How to give row name? You say index equal to. Okay. So column equal to. So first we'll say fruit. Then we will say January. Then you say February. Then you say March. Okay. That means I'm creating table with these columns. So this column will take fruit. You can say fruits. This is Jan, Feb, and March. Okay. Now you can have index name also. Index name, what do you want to give? So I want to call it as fruit 1 or something like that. Okay. If you don't give, it will have 0. Okay. I can show you maybe first. Okay. When you run it, so you see here, you have fruits January, February, March, and then 0, 1, 2, 3, and then you have this. What I'll do is, okay, I will put this here, and from here we'll remove the index. We can have all the 3 output. Oops. This is what I meant. Okay, here we will say fruit 1, fruit 2, 3, 4. And it has to be same, okay? Generally, we don't use index. Okay, we have to use column though, right? But you can name even row also. So this is how this looks like. This is the table. This is how we can take a list and convert into a table. Okay. Now I want to access the members. Here, little tricky. Here because you have, so this is very much like NumPy only, right? Okay, index, sorry, matrices only. You have to read it. Now tell me, I want to read this, these values. Okay, how do I read the members? Okay, so to read here, okay, since we have to indicate, okay, which row and which column, because row and column also has values. So we have 2 functions that we have to keep in mind. Okay, you have data frame dot loc, okay, and data frame dot iloc. Okay, and this is how I remember difference between loc and iloc. LOC, okay, and iloc. I means integer. So if you are giving the numbers, if you are giving the numbers like matrices, right, like NumPy, okay, column 0, column 1, then you use I. If you want to give name, like here, they have names, right? Okay, column 1 has fruits, Okay, row 1 has fruit 1. If you are giving names, then use LOC. If you are giving names, use LOC. If you are giving numbers, you use ILOC. Okay. Now here, in this case, what is ILOC? What is ILOCs? 0, 1, 2, 3, 0, 1, 2, 3. What is LOC here? LOC is also 0, 1, 2, 3. Because we have not given any value, so name is also assigned as 0, 1, 2, 3. So 0, 1, 2, 3 here, okay, are the indices and also the name.
Names.
Okay. Also the names by default it has given. So indices is same as name. So you can use ILOC and LOC just, fine. So for example, okay, let's go to the first case here. And I need, so I'll say print fruit production. Okay. Square bracket for indexing, right? So square bracket. Now, as I told you, right, indexing, here you have to use either LOC or ILOC. First, let's use ILOC. Okay, ILOC. Now you give the value here. So I want, what do I want? I want, let's say, row for banana and mango and only for last 2 months. Okay, so row is what? 1 colon. I need 1 and 2, right? You have to say 1 colon 3. Remember indexing concept, isn't it? So I'll say 1 colon 3. And columns, what I want? I want 0, 1, 2, right? So I want 2 and I'll say up to the end. Okay. Now, when you, let's say print slicing 1. Okay. So slicing, here I did, right? So see here. So I said row, banana and mango and column 2 and 3. Okay. So 22,900, 29,000, 19,000. Okay. This is what I got. So this is how you do based on index. Based on index numbers. Now I want to use the names. So I'll say here, okay, I'll say slicing 2 or something. Based on titles, names, whatever you call it. Okay, so I'll say, and I'll run it. Index exit code 0, that means it has run successfully and you get same answer. So in this case, since name is same, we got same answer. Okay, now let me copy this and bring it down to the last. Okay, for now, I'm going to comment this part. You run it. Absolutely no problem, same values, right? But now if I uncheck this and try to run this, you see, cannot do slicing, indexing on index with these indices. Okay, because we have already given names. So you cannot do like this. So what you have to say here is ILOC, delete the num. Okay, you give the title. So title is what both has this one. So I'm going to say list of this, list of this. Here it is fruit. We are doing second, right? Second and third. So second is fruit 1, correct? Fruit 2, correct? Fruit 2 and fruit 3. Oh, what happened? Okay, fruit 1, fruit 3. And here, okay, Again, we have to give name, which is February and March, right? February and March. Okay, you see that? You got same values. Okay, so if you're dealing with name, you use LOC. If you're dealing with index number, you use ILOC. Makes sense? And same concept, like if you have colon, I want all rows, right? If you want all rows, just put colon. Okay, you will get all rows. You know, so like that, you can put it. First is always the rows, the index, and second is always the columns, titles. Make sense? Okay.